Okay, welcome again, student. Now we'll be discussing on the part 4 of this chapter 1, which is on real numbers. Here we'll be doing with the exercise 1C, starting with the problem number 1. Find the prime factorization of the following numbers. The first one given here is 96. Okay. Now, prime factorization, what actually you know about prime? Prime numbers, they are starting from 2, 3, 5. Okay, prime number are those number which are not divisible by any number except 1 and itself. Therefore, those are the prime number, and the smallest prime is 2, 3, and then next is 3, 5, 7, 11, and so on. Okay, now doing the prime factorization, finding the prime factorization means you have to divide this given number starting from the first prime, smallest prime, by 2. If you are not able to divide by 2, then you go by the next prime, which is 3. If you are not able to divide by 3, then you go to the next prime, which is 5, and so on. Okay, here 96. Can you divide by 2? Yes, because the unit digit is a even number. Okay, now 2 you divide to this number 96. First you will go with how much? You will go with 4. 2, 4 is 8, then remainder is 1 with 6 becomes 16. 2, 8 is 16. Then 48, again you can divide by 2. 2, 2 is 4, 2, 4 is 8. Again with 2, 2, 1 is 2, 2, 2 is 4. And now with 12 you divide again by 2. 2, 6 is 12, and 2, 3 is 6. Therefore the prime factors of 96, they are 2. How many times? 1, 2, 3, 4, 5. 2 is 5 times, multiply with 3. Clear? Next we go with the second number from here, which is 48. The same thing here, you'll try to divide with the first, the smallest prime, which is 2. 2, 2 is 4. Then you have 0. 2 multiply how much is 0? 2, 0, 0, and 2, 4 is 8. Next, 2 with 1 is 2. Again 2, 0 is 0, and 2, 2 is 4. Next again you divide by 2. 2, 5 is 10, and 2, 1 is 2. Now can you divide this 51 by 2? Definitely it is no. Why? Because the unit digit here is 1. Therefore you try to divide by the next prime, which is 3. Try with 3 whether you are able to divide it or not. Okay, let us try with 3. 3 1s are 3, then remainder is 2. 2 with 1, 21. 3 7s are 21. Okay, can you divide 17? No, because 17 is a prime number itself. Therefore the prime factorization of 408, they are 2. How many times? 3 times. 3 and then 17. 2025. Now by looking at this number, the unit digit is 5. Definitely you cannot divide by 2. Then you go to the next prime, which is 3. Because why we are going with 3? Because some of the multiple of 3, they are ending in 5, like 3 5s are 15, they are ending in 5. 3 7s are 35, isn't it? The unit digit, the ending digit is 5. Therefore you try to divide by 3. Now 3 2s is how much? 3 6 are 18. The remainder is 2 with 2 become 22. 3 7s are 21. Then you are getting 1 as remainder from here with 5, 15. 3 how much is 15? 3 5 is 15. Okay, then you go again with 3. 3 2s are 6. 3 2s are 6. Remainder 1 with 5, 15. 3 5s are 15. Again you go 3. 3 7s are 21. Remainder is 1 with 5, 15. 3 5s are 15. 3 2s are 6. 1 with 5, 15, 3 5s are 15, and then 25 you cannot divide it by 3, you go by the next prime, which is 5, 5 5s are 25. Hence the prime factorization of this number is 3 how many times? 4 times. 5 how many times? 2 times. Clear? Next we go with the second number from here, expressed as the prime factor. Okay, now actually it is the same thing. You have to find the prime factorization, even though this problem they have asked to express as a prime factor, but usually you should find the prime factorization itself for this given number. Now the prime factorization of 16380, they are what they are. Now you will find the prime factorization of this number, starting with 2. 2 is a 16, 2 1s are 2, remaining 1 with 8, 18, 2 9s are 18, and 2 0 0. Again with 2, 2 4s are 8, then you having 1. This one is not the remainder, is the number you are dropping down. Therefore 2 multiply how much is 1? You cannot go with any number, you have to go with 0. 2 0 is 0, then remainder is 1 with 9, 19, 2 9s are 18, then 1 is remaining with 0, 10, 2 5s are 10. Okay, next, because this number is ending in 5, you cannot divide by 2, you'll go by the next prime, with is 3. 3 1s are 3, remainder 1 with 0s 10, 3 3s are 9, again remainder 1 with 9, 19, 3 6 are 18, again remainder 1 with 5, 15, 3 5s are 15. Again next, dividing by 3, 3 4s are 12, remaining 1 with 6, 16, 3 5s are 15, remainder 1 with 5, 15, 3 5s are 15. Okay, 4 5 5. If you try to divide by 3, you will not be able to do it. So you go by next prime, which is 5. 5 9s are 45, 5 1s are 5. And then this 91 cannot be divided by 5. You go by next prime, which is 7. 7 1s are 7. Then remainder 2 with 1, 21, 7 3s are 21. Okay. Hence the prime factorization of this given number, 2 how many times? 2 times. 3 how many times? 2 times. 5 7 and 13. Okay, the next is number 3, 49896, and they express the following as the product of the primes. Okay, that means you have to find again the same thing, the prime factorization of this given number. Now 2 2s are 4, 2 4s are 8, 1 remaining with 18, with 8 this become 18, 2 9s are 18, 2 4s are 8, 1 with 6, 16, 2 8s are 16. Again with 2, 2 1s are 2, 2 2s are 4, 2 4s are 8, 1 remaining with 4, 14, 2 7s are 14, 2 4s are 8. Then again with 2, 2 6 are 12, 2 2s are 4, 2 3s are 6, 1 remaining with 4, 14, 2 7s are 14. Then you have this the unit digit ending in 7, you cannot divide by 2, you go by next prime is 3, 3 2s are 6, 3 0 is 0, remainder 2 with 3 23, 3 7s are 21, getting remainder as 2, 2 with 7 27, 3 9s are 27. Then again 3 with 6 18, remainder 2 with 7 27, 3 9s are 27, and 3 3s are 9. Again with 3 2s are 6, 3 3s are 9, 3 1s are 3. Again with 3 7s are 21, remaining 2 with 1 21, 3 7s are 21. Now 77 you cannot divide by 3, you go by the next prime. 5 also you cannot divide. Therefore by the next prime, which is 7, 7s are 11, 77. Hence the expression as the product of prime, they are 2 how many times, 3 times, 4 how many, 3 how many times, 4 times, 7 only 1, and 11 also only once. The second from here, again you do the prime factorization of this given number. You go with 2, 2 4s are 8, 2 3s are 6, remain a 1, 4, 14, 2 7s are 14, 2 4s are 8, remain a 1 with 4, 14, 2 7s are 14, and 2 2s are 4. Again going by 2, 2 2 is 4, 2 1s are 2, remain a 1 with 7, 17, 2 8s are 16, 1 remainder with 4, 14, 2 7s are 14, 2 3s are 6, 1 with 2, 12, 2 6s are 12. Okay, then you go with the next with 2, 2 1s are 2, then you have 1, this is a drop down number. You 2, you have to go with 0 to become 0, then remainder 1 with 8 become 18, 2 9s are 18, 2 3s are 6, you are getting remainder 1 with 3, 13, 3 6 are 12, then again remainder 1 with 6, 16, 2 8s are 16. Next 2 5s are 10, 2 4s are 8, 1 from here with 3, 13, 2 6 are 12, again 1 from here with 6, 16, 2 8s are 16, 2 4s are 8. Again with 2, 2 2s are 4, 1 with 4, 14, 2 7s are 14, 2 3s are 6, 2 4s are 8, 2 2s are 4. Again with 2, 2 1s are 2, 1, then you have 7, 2 3s are 6, remainder 1 with 3, 13, 2 6 are 12, again remainder 1 with 4, 14, 2 7s are 14, 2 1s are 2. Then you have 1 3 6 7 1, you cannot divide by 2, you go with next prime which is 3, 3 4s are 12, then you have 1 with 6, 16, 3 5s are 15, again you have remainder 1 with 7, 17, 3 5s are 15 again, then here you have remainder 2 with 1, 21, 3 7s are 21. Now go with the next number, by 3, 3 1s are 3, then 1 with 5, 15, 3 5s are 15, 3 1s are 3, then remainder is 2 with 7, 27, 3 9s are 27. Now you have 1 5 1 9. If you try to divide by 3, you will not be able to divide this number, therefore you go by the next which is 5. 5 also cannot divide this unit digit which is 9, you go by the next prime which is 7. Now try by 7, 7 2s are 14, remainder 1 with 1, 11, 2 7 multiply 1 7, then from 11 remainder is 4, 4 with 9 49, 7 7s are 49, again 7 7 with 3 21, 7 with 1 7. Now 31, last you remaining with 31. Is there any number which can divide 31? No, because 31 is a prime number. Hence the expression as a product of prime, they are 2 how many times? 1 2 3 4 5 6 times, 3 how many times? 2 times, 7 how many times? 2 times, and 31. Okay, this is the you practice with this how with this problem from the first and second from here, and you will be able to find the factorization of the given number by following this method I have shown to you. Okay, now the next is that we'll be discussing on the fundamental theorem of arithmetic. What is this fundamental theorem of arithmetic? Previously, using Euclid division algorithm, we have been able to find out the SCF of two number by using Euclid division algorithm. Now, by using this prime factorization, we'll find out the SCF and LCM of the given numbers. how we'll be finding the HCF and LCM? Now, the LCM we can find out by finding this by doing the prime factorization, and then the LCM will be the product of each prime factor with the highest power. Remember this thing. And LCM will be the product of each prime factor with the highest power, while the HCF will be the product of common prime factors with the lowest power. Only the common prime factors, and that also with the lowest power, while LCM all the prime factors with the highest power. Okay, now using this theorem we'll be doing some exercise here with the problem number 4. Find the HCF and LCM of the following pairs of integer by applying the fundamental theorem of arithmetic. Now 334, 36 and 54. Now how we'll find out? We have to factorize these two numbers, 336 and 54, separately. Okay, here 336 I've shown you how factorization is done. 2 ones are 2, remaining 1 with 3, 13, 2 6 are 12, then again remaining 1 with 16, 2 8 are 16, 2 8 are 16, 2 4 are 8, 2 4 are 8, 2 2 are 4, 2 2s are 4, 2 1s are 2, 3 7 21. Hence 336 is the prime factorization of 336 is 2 how many times? 4 times. 3 how many times? 1 and 7. 54 they are 2 and 3 times. Hence the HCF will be how much? Which are the common prime from here? 2 is common, 3 is common, isn't it? And then with the lowest power, 2 lowest is 2 power 1, even though we are not writing the power 1, but the lowest power is 2 power 1, that is 2, and 3 also the lowest power is, here we have 3 power 1, 3 power 3, lowest is 3 power 1, therefore the HCF will be 2 multiply 3, which is 6. And then the LCM will be the product of each prime with the highest power. What are the prime factors of these two numbers? They are 2, 3 and 7. Here you have 2, 3, here you have 2, 3, 7. That means if you count all the prime factors, they are 2, 3 and 7, isn't it? Now with the highest power, 2 is 2. What is the highest power of 2? Is 4. What is the highest power of 3? Is cubed. And 7 is the highest is 1 only. Okay, that means 2 power 4, 3 power 3 multiply 7. 2 power 4 is how much? 2, 2, 2, 2. 4 times you multiply, it will be 16. 3 power 3 is 3 multiply 3, 9. 9 multiply 3, 27. Now if you multiply all these three numbers, you will get as 3024 to be the LCM of the given numbers. Okay, the only thing that you have to remember here is the note that I've given to you. What is HCF? How we'll find out the HCF, and how we'll find the LCM. LCM will be the product of each prime with highest power, while HCF is the product of common prime with the lowest power. Clear? Now going to the next number, number 5. Find the HCF and LCM of the following pairs of integer by prime factorization and verify that LCM multiply HCF is equal product of the two numbers. Okay. Now 26 and 91, you find out the factors of these two numbers. You will get 26 equal 2 multiply 13 and 91 as 7 multiply 13. What will be the HCF? Common prime, only 13 is here, therefore HCF will be 13, and LCM will be the product of each prime with the lowest power. 2 7 and 13, isn't it? The prime of these two numbers, they are 2, 7 and 13, and highest mean there is no more. 2 highest is 1, 7 highest is 1, and 13 also highest is 1. Therefore the LCM will be product of these three, which will give us 182. Now we have to check whether the LCM and HCF, the product of these two, is equal or not to the product of the given numbers. Okay, HCF is 13, LCM is 182. Multiply these two, we are getting 2366. Now product of two numbers, what are the two numbers? 26 and 91. Find out the product of these two, we are getting the same, 2366. Hence we can say that the product of HCF and LCM is equal to the product of the two numbers. Okay, remember this. This is a kind of rule with this which we should remember, that HCF and multiply with LCM should be equal to the product of two numbers. Okay, now going to the next, number 6. Given that HCF of the two numbers is 9, now find the LCM of those two numbers, 306 and 657. Okay, now how will you find out the LCM? Now from this last problem, we have shown that the product of HCF and LCM is equal to the product of two numbers. Okay, now this is a kind of formula. We will utilize this formula here in solving the problem number 6. Now we know that HCF multiply LCM is equal to the product of two numbers. Now HCF is given to be 9, multiply LCM is equal, the two numbers are 306 multiply 657. Therefore LCM will be this product of two numbers divided by 9. Or if you divide 657, if you divide by 9, you will get 73. Now 73 multiply 306, you will get 22338 as the LCM between those two numbers. Okay, LCM of 306 and 657 is 22338. Now the next, number 7 from here. Find the HCF and LCM of the following positive integers by applying the prime factorization method. The same thing. We have to find the factors of 24, 36 and 176. Okay, I've shown you here how factorization is being done. Now 24 ordered factors, they are 2 cubed multiply 3. 36, they are 2 square multiply 3 square, and 176, they are 2 power 4 multiply 11s. Hence the HCF will be, what will be the HCF? The common prime with the lowest power. Common, what is common? Here you have 2, 2, 2. That means 2 is common, 3 is not common, 11 is not common, because the prime factor here, they are 2, 3 and 11. These are the only 3 prime factor, 2, 3 and 11. Okay, now but the common prime, they are only 1, which is 2. What is the lowest power? Here you have power 3, here power 2, here power 4. Which is lowest? Lowest is power 2, and 2 power 2 is how much? It is 4. And LCM, the product of each prime, 2, 3 and 11. Highest power of 2 is 4, highest power of 3 is 2 and 11. 2 power 4 is 16, 3 square is 9. If you find the product of this, you will get 1584, which is the LCM of this given number, of these given numbers. Okay, we have come to the end of this part 4. Now on the next class, we shall discuss the next part of this chapter, which is on the part 5. Okay, bye to all of you.